use SwiftUI to add a LongPressGesture. When that happens, we'll display an action sheet to do two things: remove shapes and change the color. To change the color, we will use the ColorPicker provided with SwiftUI. The first thing that we need to do is add the LongPressGesture. In SwiftUI, to do this, we add a modifier on LongPressGesture, and in the closure, we just put the code that we want to execute. In this case, let's just print and run. So we can do still our usual gestures. And when we long press, we get our print. However, you may have noticed that the print was executed after I released the LongPressGesture. This is because of our scale and drag gesture. That's having a mixture of gestures, so it's best if this vanilla gesture, we do it before. So that modifier and then the draggable modifier. Let's see the difference now. Let's long press, and you see the print got executed before I release, which is what we want. Now here is where we are going to present an action sheet. In the UI kit equivalent of this video, we could deal with the UI menu controller. That's still not supported in SwiftUI, at least not without a UI view representable, but that beats the purpose of this video. So our menu, we're going to present it in an action sheet. For that, we need a boolean that we're going to be changing when we present and dismiss the action sheet. And that boolean, we use it in conjunction with the action sheet modifier. And in the content, we present an action sheet view, which has a title, an optional message, and buttons. For now, we're just going to print with the action sheet buttons. Let's long press. Okay, and there we have our action sheet. Okay, now before we execute the actions of the action sheet, we need to store all of this information in a view model. Why? Because it's going to get a little bit complicated managing the shapes all from the view. It's too much responsibility. So for that, we will have a normal class, the CanvasViewModel, and here's where we will be storing all of our shapes and where we will be executing methods like change color. Another limitation that our implementation has in the view is that we are storing an array of AnyViews. So if we were to access one of the elements, we couldn't interact directly with the shapes because it's wrapped around AnyView. For that, we're going to change the shapes class. We're going to create actually a struct, ShapeWrapper. It's going to have the color that we're going to use to fill the shape and a number, which is going to be the random number that we're generating. With ShapeWrapper ready in our view model, now we will have a published array of shape wrappers. And now the view model is the one that will be adding shapes to the array, removing of the shapes by emptying the array, and implementing the methods of the action sheet for removing a single shape and changing the color. Our view will have a reference to the view model. It's going to be an add observed object. We can add this annotation because our view model conforms to the observable object protocol. That way, when the published variable of array of shapes changes, the view will re-render itself each time this array changes. So that's the benefit you get from declaring a variable published. Now that for each changes, we will no longer have an array of shapes in the view. We will reference the shapes from our view model. We still use indices. Let's try our new implementation. Nothing should have changed. Notice we can drag, we can scale, and all of this is thanks to the fact that those modifiers have their own state. We don't need to manage that part from the view model. What we are missing is now calling the view model from the action sheet actions. So we call the corresponding method. However, we have a problem. Notice that the method that we're calling from the action sheet are not called within the ForEach function. So we don't know the index of the selected shape. So for that, our view model needs to have a reference to this index, and that's the index that we will update when we long press the gesture. Then, in the action sheet methods that we're calling, we will reference this index to search for the shape in the array that the view model has, and then we perform the action that we want to do, whether it is removing that shape or changing its color. Let's try running now, and we will see an issue with our implementation. So we can drag, yes. Now the color didn't change just because the random color was the same as blue, so we can change the color, good. Let's try removing now. See what happens? The shape is getting displaced again. Why is this? Because we're using the index as the identifier in the ForEach method. To change this, we need to stop using indices and index. We need to reference the view itself so that the ForEach knows which view we are rendering and which one we are removing, and it doesn't affect the other one. So what we want is this, having in the ForEach the shapes, and that's when we can use. We just tell the shape to render itself with the shape method, but right now we cannot accomplish that. And why is that? Because our shape is not identifiable. So ShapeWrapper will make it identifiable. The only thing we need to do for that is having a ID variable. It can be a UUID. And when we create a ShapeWrapper, we create this method. So the one creating us doesn't need to worry about it. Let's ignore the SwiftUI bug. Xcode always has issues with this, but it's not a problem. Just for safety, let's specify the ID. So instead of self, use .id. Now we're going to have issues because in our view model, we do not have the selected index as a UUID. We have it as an int. So let's change this variable. It will be selected ID. And in the LongPress, we update it. And now in our two mutating functions, we will use the selected ID to search the index of the shape in the array. And with that index, the rest of the function stays the same. Let's try now. Let's try changing the color first. Okay, that still works. And now let's try removing this one. And the other ones don't get displaced. We can also add animation to the removal. Remember, in the previous exercise, we added a transition modifier, meaning that each time we remove it, if we execute it with the with animation closure, it'll be best. Instead of using it here in the view model, let's add the with animation closure in the view. And let's test this out to see how it looks. Let's remove this one. And it applies the animated transition. Let's add more shapes. And let's see how changing the color looks. Nice. So both of our actions are now animated. What we want to do now is select a color for the shape that we are changing color. We don't want it to be a random color. So our view model will have a color variable that we will be changing. When that variable is set, that's when we will execute the change color method. Now it is up to the view to set this color. And how can the view do this? With a color picker. This is a class provided by SwiftUI, and you can use it to change from a vast array of colors. So instead of calling the change color, what we're going to do is present this color picker. For this, we will use a different boolean. And let's present the color picker in a sheet. Color picker doesn't need much. It just needs a title and a binding variable to pass on the color selection. So for that, we'll use the view model. Notice that it requires a binding variable color. However, we just declare the color as a var, but because our view model is an observable object, by adding the $sign at the beginning, it makes that selected color a binding variable. Okay, let's add this one. And let's try changing the color here. And this is not actually the color picker that we wanted. For those of you familiar with ColorPicker, we wanted this view. So this is the one that we get when we present the UI ColorPicker view controller. What happens here is that what this does is it presents the control that when you tap on it, it presents the color. So, and by the way, there's no getting around it. You need to first present the control, and that control itself handles the presentation of the color picker. So we'll need to change our implementation to present the control on this screen. By the way, our implementation with the color picker did work because as you can see, the color of the circle we selected is now orange. Instead of using the flag that we created to present the sheet containing the color picker, we're going to use it to hide or show the color picker view. We will embed it inside of a B stack and then add a spacer, since everything that's added to the C stack will have the same size, that is the size of the entire view, and we want our picker to appear on the top. Okay, let's try changing the color of this square. We have now our control on the top. Let's click on the bottom, we get the color picker, change it to green. Okay, and our square changes. Even though our implementation works, we could still polish it. We can enable a control so we can dismiss this color picker. Right now it stays there. And the other one we could add is when we remove the shape, the control should be dismissed as well. Accomplishing this behavior from the view will be a little bit complicated. Thankfully, we have our view model where we know when the actions are executed. So that's where we will handle this. So we will create a flag in the view model that will handle the presentation of the color picker as well. What we can do from the view is add a button to dismiss this control. So we'll just use a normal default button with an SF symbol as an image. And when we tap it, we call the dismiss color picker from the view model. Okay, let's try changing the color of this one. We're not getting quite the shape we're expecting from the control. Let's fix that. Also, our flag needs to be published. Since we're going to be changing the value, we need to inform the view that it changed. And what was happening before is the background and the clip shape, they need to happen in a different order. Let's run again. Let's try changing the color of this triangle. Okay, now the bottom looks much better. If we tap it, the color picker gets dismissed. we can still change the color of the triangle. And when we remove it, the control gets dismissed. And that was all. SwiftUI supports the LongPressGesture just fine. Just be careful when handling with other gestures. The ColorPicker has a different presentation, but we could manage it by handling the visualization of the control. Unfortunately, we couldn't use UI menu controller here. That hopefully will come in a future implementation of SwiftUI. Having said that, I think that our ActionSheet implementation is decent enough, despite not having the popover behavior. Hope you liked it. Bye.